Hello students, today we will learn that how a heat pipe works. Okay, heat pipe is a device which can transfer heat from one place to another by the help of vaporization and condensation of a liquid. Means, suppose we want to transfer the heat from one point, one hot point to another cold point. Okay, so a liquid medium is taken and over the hot point that liquid vaporizes. Okay, why vaporizes? Because it absorbs a latent heat. So those vapors reaches the cold point, cold region. Over there, those vapors condenses. So when those vapor condenses, they give up the latent heat. Okay, and then the condensed liquid goes back to the hot region. Again, it absorbs the latent heat, goes to the cold region. Again, it rejects the latent heat. Like this way, heat is transferred from hot region to cold region by the help of a liquid and by the help of what? The latent heat of vaporization. Okay, it absorbs the latent heat of vaporization from hot reservoir and ultimately reaches the cold reservoir. Over there, it rejects the latent heat of vaporization. Like this, heat transfer takes place. Second thing is the movement of liquid. What is the special thing with heat pipe is that the movement of liquid doesn't take place by the help of any pump. The liquid moves from hot reservoir to cold reservoir by the help of capillary action. How? I am going to tell you later in this lecture. So let's learn how heat pipe works. This is the schematic diagram of heat pipe. Okay, you can see this black colored lining is of a metallic pipe which is closed from both the ends. You can see this black colored lining. This schematic diagram is of the pipe which is made up of a conducting material which is closed from both the ends. Okay, two ends are there, two either ends are there, closed from both the ends. Over the upper peripheral surface of the pipe, there is an insulation. Okay, this gray colored entity is actually the insulation. So what is the purpose of insulation? The insulation restricts the heat to transfer to undesirable places where we don't want the heat to flow. So since from the heat pipe we don't want unnecessarily heat to flow from the entire outer surface of the heat pipe. So this is the reason that we are applying insulation up to some length of the heat pipe. However, two ends, you can see one end I am showing over here. This is one end over where heat is supplied and other end where heat is rejected. These two ends are bare, not insulated, because over there we actually want the heat to flow. Okay, now what happens? The inside of this pipe is containing a wick. Wick means a fabric type material which can soak the liquid. Okay, in case you have a cloth, fabric material, and in case you're dipping inside water, then it soaks the water. Same thing, you can take example of sponge also. Okay, so technically it is called as wick. Okay, so inner lining, inner peripheral surface of this pipe consisting of lining of a wick, which is generally a sort of fabric material. This red colored entity is the wick. Okay, all around inside surface is layered with the wick material. Now this wick is soaked in the required liquid for heat transfer mechanism. Whatever liquid is desired, with that liquid this entire wick is soaked. That's it. Okay, now what happens? Suppose I am applying heat source over one end. Okay, since this end you can see is bare, having no insulation. Suppose this is a candle which is supplying heat to one end. What will happen when heat will pass through this metallic pipe to this wick? So wick is containing the liquid, so it will absorb the latent heat and will vaporize. Okay, so what will happen when the vapors will start developing over here? Then automatically by flying they will reach toward the cold end. Okay, so since over the cold end the temperature is low, so over there the vapors will condense and convert into liquid droplets. So when it will condense, the droplets of the liquids will fall over this wick material, so it will again soak the liquid. That's it, because when condensation will take place, droplets of liquid will form. Okay, and that liquid when will fall, will touch this wick material, it will be absorbed by that wick material, and by capillary action automatically this liquid will reach to this hot end. Okay, so continuously this process happens in a cyclic fashion. Over here the liquid vaporizes and the vapors go toward this cold region where the heat is to be transferred. It rejects its latent heat. Okay, and by rejecting the latent heat it becomes liquid, so the liquid droplets fall over the wick material and by capillary action again it reaches the hot end side. Okay, the beauty of this heat pipe device is that however the heat is transferred by the help of a liquid medium, but we don't require any as such pump to make the liquid to flow from hot end to cold end. Just by vaporization, the vapors are reaching over the cold end, vaporizing of liquid over here, vapors are reaching the cold end and then condensing back, and by capillary reaction again reaching the hot end. So by this way heat is transferred from one end to another. So this is what the working of an heat pipe is. So hope you would have understood the mechanism of heat pipe. Thank you.